Here we are given four functions. We have to find out which of them are injective maps. That means which of them are 1, 1. Okay. X square plus 2. Obviously, x square is a parabola and x square plus 2 is this graph of x square shifted 2 units upwards. This is x square plus 2. This red one. If it was x square, it would have been like this. X square plus 2 is shifted 2 units up. Okay. So if it is 1, 1, what does that mean? Each x should have only one y. But here it is not the case. For example, this x, whatever is this and this will have the same y. Right? Two different x coordinates are mapped with the same y. In fact, this is failing in every horizontal test. There are multiple x coordinates which are giving the same y coordinate. Right. So that's why it is clearly not a 1 1 map. 1 1 map happens only when the function is continuously increasing or continuously decreasing. Here it is decreasing and increasing. So definitely it is not 1 1. So for example, if we restrict this function from here to the right of 0, then this can be 1 1 because then it will be continuously increasing. But here, if a function is sometimes it is decreasing and another time it is increasing, that means there will be definitely be two values of x for which the y value will be the same. For example, if a function is it just had a blip, that means there will be 2 points which will be at the same height, right? So that's why a function that is either increasing and then decreasing or either decreasing and then increasing, and there will always be some 2 points which will have the same value of y. Okay, so clearly x square plus 2 is not 1 1. If we are taking the domain entire domain as minus infinity to infinity. If we restrict it to 0 to infinity, yes, this can be made as 1 1. Now absolute value of x plus 2. How does it look? Absolute value of x will look like this, right? This is the absolute value of x. When x is positive, y equal to x. When x is negative, y equals minus x. For example, x is minus 2, y will be minus of minus 2, which is plus 2. Okay, so this same graph, absolute value of x plus 2. That means f of x versus f of x plus 2. F of x plus 2 is f of x shifted 2 units towards left. So this graph, whatever this absolute value of x, this graph shifted 2 units towards left. So that is this one. Absolute value of x plus 2 is this graph. Now, what is the domain that is given? Minus 2 to infinity. Okay, so only this part of it. Only this part of it. So it is continuously increasing, right? For any two different values of x, you will never get the same value of y because it is continuously increasing. So this is 1 1. This function is 1 1. This is an injective map. The third one, x minus 4 into x minus 5. What does that mean? This is actually a parabola again. This is in the form of ax square plus bx plus c, right? There are two roots, x minus 4 and x minus 5. What is this? This is this parabola, x minus 4 and x minus 5. These are the two roots. If you multiply that, you will get x square minus 4x minus 5x plus 20, right? X square minus 9x plus 20. So this equation is same as x minus 4 into x minus 5. Here also clearly we can see even at 4 and 5 the value itself is 0. Y is 0 and x is 4 or 5. What does that mean? There exist at least uh, for two different values of x, the two different x's 4 and 5 are both are mapping to 0, which is not possible if it is 1 1. 1 1 means it is either continuously increasing or decreasing. This it is like the same graph, right? So now it is not 1 1, it is not injective map. So one x should give only one y, then only it is injective. Now the fourth one, 4x plus 3x minus 5 by this thing. Rational this is a rational equation, right? It's a ratio of two quadratic equations. But we don't need to worry much about this because if you see the numerator, 4x square plus 3x minus 5. What is there are definitely two roots, right? B square minus 4ac is 9 minus 4 into 4 into minus 5. This is definitely greater than 0. That means, and the A is positive. What that means? What that means is this graph is facing upwards and touching x-axis at 2 points. What are the 2 points? Those are the roots. We don't need to calculate the roots. What does that mean? This graph is actually numerator is touching x-axis at two different points, and definitely the denominator is it's a different equation, right? These the roots of this equation and this equation are different. So this must be touching at two other points. It doesn't matter. But whenever this equation is um, touching x-axis at two different points, the value of this ratio will become 0, right? Because the numerator is 0, 0 by something, 0 by something. Whenever are the two roots, for example, this root is 1 and this root is 4, in both the cases, the value would be 0. Then because the numerator is 0, whatever are the roots, we are not concerned about the roots. In both the cases, the value of this fraction is 0. That means there are at least two different values of x for which value of this fraction is 0, right? Two different values of x, basically which are the roots of this equation, for which f of x is equal to 0. That means two different x values of x are mapped to the same value of y, which is equal to 0. So clearly we can say this is not 1 1. If it has to be 1 1 or injective map, that means the fraction has to continuously increase. Here it is definitely not continuously increasing because it is touching 0 twice. It is touching x-axis twice. So probably it is like this or like this. It doesn't matter. Or it could be like this, right? There would be some asymptotes. It doesn't matter. But at least there are two different for two different values of x, which are the roots of the numerator equation in the numerator. The value of this is actually 0. That means they are referring to the same y coordinate. So this is also wrong. So only correct equation is this one. Right. Remaining three, for A and C are parabolas clearly. So and parabolas over the entire domain, they cannot be 1 1. And this one, this is fraction of two parabolas. Definitely it is 0 at two different points. We have realized which are the roots of the numerator. So this also cannot be an injective map. Right, guys?